Now let's go ahead and talk a little bit about what is inside of these atoms, the electrons, the neutrons, and the protons. And we've talked quite a bit about it already, but let me go ahead and write it all down. So we have the proton, right? We have the proton. Now the symbol of the proton is like what we talked about, P with a little plus sign. So proton, P for proton, the plus means it has a positive charge. Now over here I'm going to label a heading up here, and I'm going to write this down, approximate relative, R-E-L, a relative mass, right? This is what a column heading I'm going to write. And then I'm going to write over here, approximate relative charge, R-E-L, charge, okay? Okay, so what we're going to have is, for a proton, the approximate relative mass. I haven't talked to you about this, but I did tell you, protons and neutrons are in the center of the atom. What we talk about, we say a proton has an approximate relative mass of 1. Now, let me explain a little bit about what relative mass means. What it basically means is, if you could take a single proton, and if you could put it on a balance and actually take its mass in units of kilograms or something, you would have an incredibly small number, because remember, a proton is a teeny tiny part of a single atom. So if you actually measured it in kilograms, which I'll tell you what the number is in kilograms, but just take my word for it, it's an incredibly small number. It's got many, many, many zeros right after the decimal point. You finally get to some digits over there. So in chemistry, rather than talking about these teeny tiny numbers of kilograms, we just say, hey, look, we're always talking about atoms. That's what we're always going to be talking about. So when we talk about protons, we're just going to say, okay, a proton has a mass of 1. What unit? Just call it a relative mass for now. It's got a relative mass of 1 because we're always going to be talking about protons, neutrons, electrons when we're talking about the nucleus in the atom and the electrons in the atom. So we'll just assign it a value of 1 and go from there. All right. Now next we have, instead of a proton, the next guy we have is a neutron. And I'll fill the rest of the table out here in a second. Neutron. And it has a symbol of N. There's no charge here because it doesn't have a charge. Now its approximate relative mass, or for this class, we're going to call it also 1. Now let me give you a footnote here. The relative mass of a neutron is not quite 1. It's actually slightly different from 1, but it's so close to 1 that for all practical purposes in chemistry, you can think of the proton and the neutron having the same mass. They don't quite have the same mass, but they have so close of a mass when you measure it in the laboratory that for the purposes of chemistry here, we're going to basically say that the mass of the neutron and the proton are basically exactly the same thing, and we're just going to assign it to 1. 1 relative mass, proton, neutron. So when you look at an atom like this, you have 2 protons, 2 neutrons. The protons have the same mass, we call it relative mass of 1. The neutrons each have the same relative mass, again, relative mass of 1. The only real difference is the neutrons don't have any charge and the protons do. All right, so let's go talk about the next guy, which is going to be the electron. And the symbol of the electron is an E with a little negative sign because it has a negative charge. Now, what is the mass, relative mass, of an electron? Well, on the scale that we're talking about here, where a proton has a mass of 1 unit, whatever that unit is, neutron has a mass of pretty darn close to 1, so we're going to call it 1. An electron is much, 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 much less massive than either of these two guys. So an electron has a relative mass on this scale of 0.000545. And we're talking about relative mass. Relative to what? Relative to a proton. If a proton has a mass of 1 unit, then a neutron is also, for the purpose of chemistry, going to have a relative mass of 1 unit, but an electron is going to have a mass much, much smaller than a proton or a neutron. So look at that for a second. That's really kind of amazing. The protons and the neutrons have all the mass in this atom. The electrons, yeah, they do have mass, but it's such a small mass that it doesn't really contribute that much to the mass of the atom. But it has an equal and opposite charge to the protons, which we're going to write down right now.